Okay, Kubernetes. So we have studied Dockers, how we can make containers. We can pack our application inside a container, and then we can push it to the repository. And anyone on the development, on the testing, or the QA, or the production, or the staging can download that Docker and test it or run it. But that is a limited setup. We have one Docker image which we can run, and we can have our Apache, PHP, MySQL container, and that's it. But if the application, we have a lot of containers for our application, because we have a huge application which needs hundreds and thousands of containers to run. So it is very difficult to manage those containers through scripts and the files we used to create in Dockers. So Google developed a tool and named it Kubernetes. What is Kubernetes? Kubernetes is an orchestration engine on top of Dockers. So everything is managed by Kubernetes, and we don't interact with our containers, and we don't create or destroy our containers directly. So everything is done through Kubernetes. Kubernetes gives us a lot of advantages, like we can scale up, scale down, replicate our containers, just like doing the small configuration changes in a file. We will see it later. And it is very easy to scale up, scale down, load balance. We can achieve disaster recovery. And the Kubernetes is actually is deployed in clusters. I mean, you can have multiple nodes belonging to single cluster, and the cluster is self-healing. What's the meaning of self-healing is, if a container is destroyed, if it is crashed, it will be recreated automatically. We don't need to do anything. So again, Kubernetes offers various features, including high availability, scalability, and disaster recovery. We will see what all these things are. So Kubernetes has lots of components, but we will be discussing very main, basic, and the most used components, like pod, service, ingress, config map, secret, replica set, deployment, states, volume, etc. So these are the components of Kubernetes, the major components of. Okay, so container, we had our container as our smallest unit, but in Kubernetes, we will not use container or the word container anywhere. The smallest unit is pod. And the pod actually is an abstraction over container. Like the pod has a container running inside it. Every pod gets its own IP address, like not the container. The pod gets the IP address. So this pod, this is the smallest unit, and it gets its own IP address. And let's say this is our application pod. This is our database pod. So these both pods are running on our worker node. This is our worker node. So they can communicate with each other using IP address. And this IP address is automatically assigned when a pod is created or recreated. So if a pod is created, IP is assigned, and if the pod is crashed, we can and recreated, it will have a different IP address, and it will be decided by your the Kubernetes automatically. So there comes a problem. If our database pod is destroyed and recreated and the IP address is changed, we know from our previous lectures that our application connects to database through the IP address or the host name. So if IP address is changed, then our application will not connect to our database. So there is another component which solves this problem. The service component is like, it's like the permanent IP address. So we attach a service to our pod, and that service actually connects to the IP address. The service is like load balancer. Whenever pod is destroyed and created, it is linked to the service, and service take care of our communication, not the IP address. So if the IP address is changing, it doesn't matter because the service knows where the pod is created and what's the IP address of the pod. So the pods communicate not through IP address, it communicates through the service names. So let's say this service is Apache PHP, and we can name this service as MySQL service. So pod 1 or the pod app will communicate with our database using this service. And the theory is the same. Okay, first of all, interrupt me whenever you think you don't understand anything, because everything depends on this theory, and every lab is covered using these all concepts. If you don't get it, it will be very difficult for you to implement the labs. So service is like a load balancer. It's like a permanent static IP address, which we used in the traditional environment. And service has two types. External service, we defined it actually that this is an external service and this is an internal service. So what's an internal service? We have our database. We don't want to expose our database to the whole world. So we will attach an internal service to it. And the app is our website. So external world wants to communicate to our app because they want to see our website or our app. So we will attach external service to our app. And then the request goes to from external service, it will go to my app, and my app will through internal service communicate with my database to pull the data. So that's the concept of service. And the service listens on IP and port. So let's pause the share and we can go on the board. So can you go on the board directly, or should I stop the share?
We go on the board already.
You are on the board.
Yes.
Okay. Now I have to stop the share. Can you see it?
Yeah.
This is our physical node. Let's call it worker node 1. We have pod. A container is running inside a pod. But we don't interact with our container directly. The smallest unit I told you is the pod. So we talk to our pod, and pod is an abstraction layer over container. So service an IP address. We don't care what the IP address is assigned. We just do care what service name is attached to that pod. And service can be internal and external. External services like anyone coming from outside the host can connect to this app through external service, and they can communicate internally by using internal service. The problem with service is service listens on IP address and port. In our testing environment, we can do the testing like this is the IP address and this is the port, and we can browse our application. But for the world, we have our DNS record. Which tells the website is running on, let's say, http://abc.com, port 80. So abc.com and port 80, this is done by another service called ingress. So now the request will come to ingress. Ingress will send it to external service. External service through internal service will send it to the database, and this will be the complete flow. Any confusion till here? I guess no then. we can go ahead. So okay, the laptop screen is there.
Yeah.
Yes.
So we were discussing ingress. So the request comes to ingress. Ingress, from ingress, it will go to your service, external service, or from your external service, it will go to your internal service and connect it to the database. The problem is, for some reason, you have changed the service name my database to my Oracle database or my MySQL, my MariaDB. I mean, you can change the name for some reason. The problem is your app has connection defined that you will connect to this service. So as your app, in your app's connection string, where we tell that connect to this DB, connect to this connect using this username, connect using this password, and connect through this DB host. So if that parameter is changed, you have to rebuild your application with new connection string, and then you can pack that application in a container, and then you will push that container to your repository, and then you can pull it again in your Kubernetes configuration. So to avoid that, we have another module called config map. So in our config map, we define our variables like the external variables. We can define the database host or the database username or the database password. So, okay, it is a repetition DB name and DB username. And these are our external configuration. So my app will see the config map that what is the host, and in this host we will define that our host is our this service. So if we change the service name here, we will just tell the DB host that you can, the application will have the same DB host, but on the back end we will tell that it will connect to this service. So config map is, we define external variables in config map. We will see everything in practice. So the problem with config map is, I mean, every module solves some problem, and then there is some further problem which is solved by some other module. So if in a config map, which is a plain file, we can write database host, that's perfectly fine, no issue. But the username password in a clear text format, we don't want to do that. So there is another module which is in which we define the external variables, is called the secret module. And secret stores the data like your keys, like your passwords, like your database connection strings, everything in encrypted base64 encrypted format. Okay, I think if it is clear, then I can continue. Otherwise, I can go on the board again.
Yeah, so far so good.
So far, so good. So Harshita?
The Harshada, she only said.
Okay. So we are continuing.
Yeah.
Okay. What I was telling you in the secret, we define the base 64 encoded username passwords, and we call that file in our config map. Okay, what is a replica set? We have one container. And when working with Dockers, when we deploy a Docker, it is
Clone.
one container created. The replica set is whenever a pod is created, it always has one replica on another worker node. Let's say we have another worker node. So one pod is created, the replication pod is created on the other node. Let's say I want to say that no, I have 100 pods available. I should have 100 replicas available. So in our configuration file, we just tell replica set is equal to 100, and it will create 100 pods automatically, and everything will be attached to this service, and service will start load balancing across those 100 pods. Okay, the peak time is gone, the load is gone. You can say now reduce the pods to 10. So we will just define replica set value as 10. You don't need to configure anything else. You don't need to configure any cloning or replicating. Everything is done automatically. And if though in those 100 pods, your 10 pods are
Is it
destroyed,
something auto scaling?
the replica set configures it automatically. This is auto scaling.
Yes, yeah.
You don't need to do anything. And if your pod is destroyed somehow among those hundreds or thousand pods, let's say 10, 20 pods are crashed. So they are automatically created because it will be the Kubernetes cluster will be always checking the cluster that what is required, what is present, and what needs to be created again or whatever. So this is a self-healing cluster. That's why I'm saying it's a replica set. You define the value and then it's a self-healing cluster. Everything destroyed, it will be recreated. So the ingress will come to the service. Service will load balance the pod and they are replicated. In case of our database, if our database pod is destroyed, what will happen? We have replica available.
Automatically move to other node.
But there is a problem. Database cannot be replicated like that because the database has tables and tables are in locking and unlocking state. So one container table is logged at a time with one process. So databases are not replicated like our applications are replicated. It is pretty straightforward, simple to replicate a website, but it is not that simple to replicate our database or our stateful applications. So there is another module that when we define our databases, we define that as stateful set. And through stateful set, we can tell that this application is my database and it is retaining the state so that when one write is committed, then the change is replicated and so on. So it is a bit complicated. I have not deployed it stateful sets and I'm not doing it here. And it is not usually done that databases are running in microservices. The databases are still there in a traditional environment. So application are containerized, but the databases are running in the traditional way on a traditional system. Okay. So the deployment. Deployment is we had made our YAML files, and before that we were creating the containers through command line, but we saw that working with YAMLs is and Docker Compose is a way better, that your containers are created with just one command, Docker Compose, and they are destroyed the same way. You don't need to individually go and delete. So in Kubernetes, when we have so many components, we have pod, we have service, we have ingress, we have config map, secret. So to manage everything, we have our deployment. Deployment is what? It is our configuration file. And it's the blueprint in which we define this will be our pod name, this will be our service. We have this many replica set, and so on. So through Replicaset, we can change the value and we can scale up or scale down. So everything is controlled through this deployment configuration. So stateful set, I have explained you what stateful set are. All the applications which persist state, like our databases, we deploy those containers through stateful set. So I am going on the board again, or yeah, I'm going on the board again.
Jishan,
Yes,
Replicaset, is there any limit? Those things, those configuration changes will be done in blueprint. Am I correct?
yes, in the blueprint. And the limit is your physical resources. Otherwise, I think there is no limit. I mean, how many pods you want to spin? 1,000,
Minimum
10,000?
is one, right? Replica minimum is one.
Minimum
per-
is one.
Okay.
So first, let's say you have a pod. You have ingress. You have external service. So traffic comes to ingress. Ingress will send to external service, which will send it to internal service. Okay. So external service is attached to our pod. And there is a my app running on it. My app pod. And internal service is running to, I mean, that is our DB pod. So they will communicate through internal service, and external service will communicate to this pod. We have our config map, in which we will define our database username and password and some other variables. And the config map takes some data from the secret, like user password. So this value is taken from a secret file. So ingress, external service, internal service, config map, what is left? Let me see the components. Yeah, service, ingress, config map, replica set. The replica set maintains the replicas. And then goes our deployment. So architecture. So these are the core components or the most used components. Now how we define our cluster? We have one physical server, we have the second physical server, we have further servers. So let's say we have 2 into master nodes or control plane. And these are our worker nodes. Worker node 1, 2, 3. These master nodes, they have some processes running on it, and on these worker nodes, we have some other processes running on it. The most basic process is the Docker engine. So that a pod can create a container, or you can run a container. There will be an abstraction layer, but still the container is running inside it. And this is controlling that which container or which pod is created on which physical node. There can be 100 of physical nodes, but the master nodes, they don't grow that much because they are just doing the control part. The real workload is running on a worker node. So this is the architecture, and if the other node is added, one more node is added, it is added through this control plane. Control plane will add another node and it will say that, okay, this is the least utilized node. So let's say spin some replicas here. There is too much load on this physical server. Maybe 3-4 pods are destroyed here and recreated here. So pods are created, destroyed very frequently, even just to load balance. There is no vMotion concept here that you can move the machine from here to there. So let's share it again. Kubernetes, okay, I told you that the control plane and the worker plane. Can you see the screen?
Yes, the presentation.
So on the worker nodes, I was telling you we have a container runtime that's called, Docker runtime. We are using Docker, or maybe there are other microservices tools. And there is kubelet. So what kubelet does is, kubelets actually, that it's a process, it's a service that actually manage all the work, like creating the container, recreating, and everything is done on worker node is through kubelet. And the services, we know the services is like the IP address and the ports. So it controls the load balancing, the networking, external, internal. So networking part is all handled through the services module. And the kube proxy. Okay, I think I have explained it in the animation. What kube proxy done is, it actually optimizes. If you have an app container, you have a database container. Okay, I will explain it later. Let's say it optimizes which traffic goes where. Yeah, I have explained it. So we have our pod, our application pod, and our data pod. Let's say database pod is running on some other physical node. So the traffic can leave this pod and it can go on node number 2, and database is still there because the service is load balancing it. But that is the wastage of resources. It will add network latency. So what kubeproxy does is, if it sees the pod is running, this pod is running here, so it should connect to the database server on the same physical node. It should not, the traffic should not travel a lot east west. It should remain in the physical server as much as possible. So I may have 100 application pods and 100 other pods, and every pod will be talking to each other, and kubeproxy will make sure that the traffic does not leave the host until it is necessary. So it is the intelligent forwarding engine. Okay, so on the master nodes, we have API server, we have scheduler, controller manager, and etcd. So these 4 processes are on the master nodes. What is an API server? Every request comes to the control plane, goes through API server, it validates the syntax, it authenticates everything, and when the syntax is correct, or let's say if you want to get the status of your cluster, you will come through, you will do kubectl get nodes, get pod. Every request will come to this API server, and it will forward it to the respective further service by realizing what command you have typed. So everything goes through this. This is the gatekeeper. This is the entry point. So everything comes through the API server. Okay, the scheduler. The scheduler is what? I think I have explained it earlier. Yeah, I have explained it. So API server receive, validates it, forward it to the scheduler. Okay. What scheduler does is, it has the complete visibility of the worker nodes, that which node is how much utilized. Let's say one is 10%, one is 20%, one is 60%. So when a new pod is created, scheduler sees that this pod should be created on the node where the resources are maximum available. And how it does is, it has the states of, let's say we have 3 worker nodes, it has the states and resource utilization, and this scheduler will forward the request to the, I have told you, kubectl process is running on the worker node. So it will tell the kubectl of that worker node that just create this pod. Are you guys with me?
Yes.
Yeah, Shan.
I don't think so. I mean,
This
yeah, this is a lot to
so much
absorb.
theory, na? So
This is a lot to absorb. I know.
yeah.
This is a lot to absorb. So we had discussed the components, just leave them here. We are just theoretically seeing what the processes are. So the scheduler API gets the request, it's sent to some scheduler. Scheduler is what? It is scheduling where the pod is created, and how it will send the request to the worker node, and on worker node the kubectl will receive that request and spins the pod. That's it. So scheduler is just scheduler. The controller manager detects the pod's failure on worker nodes, and if the pod is died, it tells the schedule to, yeah. Okay, controller manager will see that a pod is died on the worker node 1. What it should do? It cannot tell the kubectl to create another pod. The control manager will tell the scheduler that the pod is died, so you know where it should be created. It will observe the resources availability, and it will tell the node, the particular node which is less utilized, through kubectl that create this pod because this is destroyed. So controller manager has the visibility what pods are destroyed, what pods need to be created, and it does it through scheduler which goes to the kubectl. And there is a etcd, whatever you call etcd, etcd. So it's actually brain. It stores everything inside
good.
its database. And every component, the API server, the scheduler, the controller manager, every component takes information from this store and decides what it should do. The resources consumed on the nodes, it is stored in etcd. The pods are running there and crashed. So the controller manager will compare the states on the nodes and etcd, what should be there and what's not running. So if the states are not same, let's say maybe we need to create some more pods. So etcd is the brain of this master node. So any confusion till here? No?
Go
Or I
ahead,
can
go ahead.
repeat.
You continue. I mean, you can continue.
So the theory is done. We are done with the theory. So what we can do is, you have let's say, I hope. So I have shared two links. One is this. Can you see the screen?
Yes.
So this is
Minikube.
minikube. You can select Windows, Mac, or I don't know about the Mac OS guys. Then x86 64 stable version XZ download and click on this latest release. When you click it, it will pop a download. Okay, you will save that file and run it. Make sure that you run it when you are installing this application. You either remember the path or make a new folder in your C drive with the word minikube, and you install it directly to the C/minikube directory. And then when the installation is complete, you will by clicking the kubectl exe, I have the second link available for you. I think I can copy paste it and I can show you. Control C. And this is the second link. When you will go to this link, it will start downloading this kubectl.exe, and you will save this file in the minikube directory which you created earlier for this application. So it will look like plus the third command. Control C. And I am going to paste it in the group. So what it will do is, I have installed minikube in my C directory in minikube folder. So I am setting the path that I don't need to go in minikube folder every time to run a command. So I'll be on my command line anytime, and from anywhere, from any folder, I can call these kubectl commands. So I have to export this folder in my environment variables. The third thing is you just do minikube start, and it will by default minikube start. So I have shared the in WhatsApp group. When you will do the minikube start, it will automatically pull an image of a VirtualBox. It will do the networking, everything, and it will. But even I can share you. Let's say, okay, just give me a minute. Where is minikube? Yeah, that is. So I will press shift right click and open in PowerShell. So what I will do is I can show you our VirtualBox. That I have VirtualBox and everything is powered off. Let's say I do minikube start. So it is restarting existing VirtualBox VM, and you can see it's running now. But for the first time, it will download this image and it will configure this machine. And then you have downloaded kubectl.exe. I have copied it here. So I want you to do it this before next class. And okay, it is doing what it is doing. It will take some time and it will come back. So I was telling you this install this minikube kubectl, and so that you can practice all the labs through minikube. I mean, we are not working on a real cluster, but it will behave like the real cluster, and that's it. So any question till here? I think I am stopping the share.
Yeah, you already did. Recording.
The recording is like stopped? No.
Not